go ahead and start, and then I'll take roll. I'm sure there'll be 2 or 3 come in 5 or 10 minutes. So I'm going to wait a couple minutes to take roll. But first thing I wanted to make sure, I had a couple of students, but it may have been online, I can't remember, that didn't get into MindTap because they didn't have their money. So I wanted to make sure you guys realize that you can get in there for 14 days without paying anything. Did anybody have trouble doing that? Everybody got in? Okay. All right, so I have uploaded both our lectures here, but something that I wanted to go over is that from now on, I won't post an announcement. And of course, these are not lectures that you're required to watch unless you want to go over them again. And unless I miss a class, and I will post up here, like I may do a little video if I'm going to be out or something. I only anticipate that for one time that I'll let y'all know about. But down here is the Zoom meeting link. And so this is if you wanted to come into class, but then this is our YouTube link where all those videos will be from now on. So they won't always be up there in that announcement like that, but anytime you want to go back, or say you miss a class and you want to see the video, then this link will have a playlist that has, it'll have both this class and my 12:30 class. So you want to be sure that you look at the right one. I'm trying to keep them right at the same place, but of course, because they don't meet on Mondays and they watch your video, there may be some things that I answer there, and so you're welcome to watch them. I'm just saying there's one for that class on Wednesday. So on Wednesdays, I record twice, in other words. Okay, so today I wanted to be sure that everyone's read Unit 1, and you have until tonight at midnight. It always says 11:59 because somehow these clocks in here don't work right. If you put midnight on there, it doesn't do right. So I always have to put 11:59 p.m. And so today we're going to go back over. I am going to use the PowerPoint in MindTap, and we're going to go over what just kind of review what I covered at the beginning and show you. Then we're going to skip down and do some of the exercises that were not assigned, so that you'll know how to do your homework assignment. And this chapter, actually, we're going through it quicker than we will some of the other chapters, because this is just an overview kind of the terminology and that you're going to be using all semester, and then some of it pertains to other programming. If you take other languages that we talked about, like compiled languages and so forth, then it talks a little bit about the differences of that. And so most of you, this is the first time that you've been introduced to this, and so that's why we're going to review it a little bit today. And let me see. And if you scored real poorly on the pre-course assessment, you're supposed to, unless you're a programmer already, so don't worry about that. Okay, so here is Chapter 1, and here was the preview, and this was where I was just going through the chapter. And since I'm kind of reviewing this time, I'm going to go into the study here, and you can pull these slides up yourself, or you can, if you can see up front, you can watch them from up front. Either way, that's best for you. Last slide view. No, I don't want to. Okay, so let me get it big screen here. All right, so this was the chapter that we started last time, and the whole chapter, these are the objectives that you'll read about in here. So we talked about the differences and what a computer system, what all it takes to make a computer system, the difference in hardware and software. We talked about application software, system software. We already talked about the three parts of every program has to have. It has to have input, processing, and what's the one that's not showing up there? Output. Good. So every program, no matter how difficult or how simple it is, it has to have those three parts to it. And sometimes, like your processing may have several steps, so it may have quite a few of the rectangles. Then there are different kinds of programming languages. And the one that it's talking about here, you'll notice none of the scripting is listed, because even though to you it's like a programming language, scripting really is different than a programming language. Although people who primarily do scripting these days, they think it's a programming language. But what makes it different, can anybody tell me? What makes a programming language different from a scripting language? If you program in C++ or C#, remember we talked about that the program has to go through a compiler, whereas a scripting language has an interpreter. And the difference is you immediately see the results with a scripting language. With a real programming language, you have to code it in what you think is a language, but it's still not in machine language, remember? So a compiler puts it into machine language, and then it can be executed or run on a computer, but not until then. So that's the difference. So we're not going to be dealing with those type of languages in this class. But if you are getting an IT degree, a programming degree, then you will be taking some of these languages. I forget how many in here are going to take another language besides scripting. Jamie, what's your name?
Colby.
Cool. Okay, so you will be taking one of these after, so that's why it's important that you learn the generic pseudocode for solving a problem, not just the Python, because then you can take that pseudocode and flowchart and implement it in other languages, as long as you learn how to solve the problem in this class. Okay, but it's no fun if we don't have something to apply it and see it run. Then the syntax, remember, just the normal mistakes, like every language has its own syntax rules, where there has to be a semicolon, where there has to be a colon, if you misspell something. Those are syntax errors, just like they are grammar rules in other languages that you speak. Okay, we talked about memory. And here I just told you the difference between a compiler or an interpreter. So even though we're coding source code, it doesn't get into machine language except through a compiler or an interpreter. And they also are what checks the syntax errors, the compiler or the interpreter. And when a program runs, that's like in Python, we run a program, but in most languages, you execute. Like in Windows, it creates a .exe file, which is an executable file, it's called. So these terms you should have covered, like if you haven't taken Unit 1 test yet. These are the things, these are the most difficult errors to find. The logic, which means that you didn't get the correct answer, or it's hung up in a loop and the program doesn't end. Well, that is a logic error. Logic of the computer program is the sequence of specific instructions in specific order. And so then what we're going to talk about, what you have one assignment where you first watch that guy on the tutorial, is called variables. And a variable we talked about is a named memory location whose value can vary. So even though you name a variable like, say, num1 or num2, it's a memory location, but that value can change depending upon when you're running the program, what the input is. You had variables in algebra. It's the same thing, like only the difference is in algebra, you use like X's and Y's and A's and B's, and you still can do that, but it really makes no sense because you forget what that X stands for or what that A stands for. So in programming, we give our variables more meaningful names for what kind of value they're going to hold there. Okay, so that's the difference. I did have a programmer a few years ago, and probably more engineering students like to use just single letters because they're used to, if you're a mathematician, a lot of mathematicians think like that. But most of us don't think like in X. We want to know, what is that X? You know, what does it hold? All right, the program development cycle, even though this whole, and in your book there was a little diagram of it, understand the problem. That's gonna be our number one thing, planning the logic, and we will only get to code the program when in Python. So we'll use the interpreter to translate it, and then we'll test the program with certain values, like when you put certain input in. And when I give you the hands-on test, I'll say, try your program with these values and you'll get this output. And I'll show you what the output should be. And if you try your program and it doesn't get that output, then you know that something's wrong in the logic. Okay? Then we won't be doing these two steps. Put the program into production. When you work on a project team or even an individual, if you work for a corporation or a large company and you're a coder, there's usually what they call quality control, where before your program goes live, it goes into a quality area where people test it further. And once they decide, okay, it's not going to crash the system, it's going to work right, then they put it into production. And then there's always changes that have to be made. Most of the time, if you get hired to be a programmer at someplace like tax commission or a Microsoft or something like that, you will first be maintaining other people's programs. Very seldom do you get hired to be a coder that codes your own stuff in the beginning. Usually, most often, it is to modify somebody else's program. That's why it's important to learn how to solve problems and to read how the logic flows so that you can go back, and you also want to comment your program so that you can see it. Here's the cycle that I was talking about. So we'll be doing first understanding. We'll read the problem, those exercise problems at the bottom. We'll plan the logic. We'll write the pseudocode and flowchart first, and then we'll write Python, and then we'll use an interpreter, which just simply means on Python, you click the run button, and it translates the code, and then we'll test it with specific data. And then we won't do these two steps. All right, so here we go. One of the most difficult aspects of programming is understanding the problem. And that's what you're going to find this semester. That's, if you can understand what they're asking you to produce, that's the biggest part of this class, is being able to solve the problem, the business problems. And some of you, since I have quite a few engineers in here, I'm going to try to find some that we can do in class that are more engineering problems. I used to have some in here. Documentation is all supporting paperwork for a program. That's where, as we go along, we start out with pseudocode and flowchart. And then later on, I let you have the option of commenting your Python, which is the same thing sometimes as pseudocode if you do detailed commenting. In other words, when you say add or sum equals A plus B, then out to the right, you would say, I'm adding two sales items to get the output or whatever. You have to put the comment in the program code so that you know what that code is doing. So planning the logic, plan the steps of the program and what they include. An algorithm is the sequence of steps or rules you follow to solve a problem. So most common planning tools, this is what we'll be using. Desk checking is where before you run it in the Python code, which Python makes it so simple that most people bypass the desk checking. But when you get to other languages like Java, C++, you can take your values and run them through the program and see if the output is the same. And so that's without using the computer. I used to always, like when I was telling you about the COBOL programs in a stack this high, and I only got to run them 3 times a night, then I had to have tested that to see if it was going to work. And that way, I knew pretty sure if maybe I had some syntax errors or something, but I could go through the logic and it made sense. So hundreds of programming languages available. Coding is easier than the planning step. And that's why we spend this semester planning to solve problems, because that's the part that everybody wants to skip and just start writing code. But the thing is, if you don't plan out how to solve the problem, when you get to larger and larger problems, then you are repeating some of the things. You have to keep trying to go back and find out where the error is. So it's really a good idea to plan it. Okay, here's the translator, the syntax error. I'm not going through that part because this is an important part. I'm just you should have been tested over it. I want to get to where we can do some exercises. So here's logic error and testing. Debugging is the process of finding and correcting program errors. Programs should be tested with many sets of data. And so that's what I'm telling you. When I give you a test, I'll give you 1 or 2 sets. I'll give you probably at least 2 sets of data so that you can see if in different situations it works. It's not as big a deal when you have just no if statements or no loops yet, because 1 set of data is going to work correctly to test it. Okay, process depends on the program's purpose, conversion, the entire set of actions an organization must take to switch over. Okay, this is what I told you that I did in industry many years ago. As I was a conversion programmer, I wrote online programs too, with data entry, but then in banking, we started converting banks from one computer system to another. And so what that means is that the data has to be taken, like, say, where a person's name, maybe their first name was here and their last name in the file was here. And when we converted it, it switched them. The new system wanted them switched. So you had to say, move first name to first name 1 in another file. So conversion is where you take the data and change it and switch it to a new system. And banks do that all the time. That's, or not all the time, but they have updates to their system and they add things and you have to go in and convert that data. What happened when I was doing that, first, we were going from an in-house where they would ship all their work to us every night at Liberty Data Services, and we would process their data, send them back their reports. Well, small banks in little podunk towns like Granite, Oklahoma, and Cordell, and all these places, I can tell you all these tiny towns in Oklahoma, they decided they wanted their own computer system. So they wouldn't have to send their work out. And so they got their own computer, and so we had to convert their data. And that's one of the times. And then the other times was when all the bank closings that you guys are too young to remember happened in the 80s. We lost lots of banks and they were bought out. Okay, so maintaining the program, this is where you go in and make changes to certain things. And like this is Tony, this is usually your first programming job, is that you go in programs. And that was when I first started to work at the State Tax Commission. I had COBOL programs that I had to go in and modify them for that year's tax. So those are things that you do first. Pseudocode, flowchart, we've already talked about all that. We did this. Here's some standards, but what it tells you is people actually can do like 2 words for start and end, or start and stop, beginning and end, just so you use, like some people will say begin at the top and end at the bottom. Pseudocode isn't running on the computer. So it's the code that you're going to look at that helps you to code the program. Okay. So like, for instance, down here for output, in your pseudocode, you can say output sum or output whatever the variable name is. But since we're coding in Python, some students go ahead in their pseudocode and say print, because in Python you have to say print, right? So sometimes you'll adapt the pseudocode to whatever language you're coding in, and that helps you to convert it over. So there's not hard and fast rules. Whenever a module name is used, it is followed by a set of parentheses, and we're going to talk about that later, but there's modules that you can set up in every language. Sometimes they're called functions, sometimes they're called methods, subroutines in COBOL. Program statements are indented a few spaces more than the word start or the module name. So we did that last time in Lucidchart. So here was something that I sort of covered in Lucidchart, but if you want to go back and look, when you do your flowchart the first time, I'm going to watch these shapes you use. You can't just pick any shape and use it. What if it's input or output, you're going to use the parallelogram. You can stretch it and make it bigger, but that tells me by a glance which part is the input and which part's output. Processing symbols are the rectangle, and you may have more than one if you're doing more than one calculation. Some people put more than one calculation inside the rectangle. It's harder to see that way, but it is okay to do that. And then the terminal symbols are the start and stop. The arrows are called flow lines. So these are the symbols that you will be using in this very first assignments that you do, and also the very first test. You won't use any more than those because we haven't done decisions yet. So I don't want to see a diamond shape on yours unless it's a if then else. Okay. So those are the only shapes that you'll be using for this first test. And here's the one like what we did in Lucidchart the other day. So that's the first one. Okay, now we didn't talk really about loops, so this is probably the new part that I didn't get to, called repeating instructions. A program in figure 1-7 only works for one number. So that previous one that we just looked at, that only works for one number that you put in, and then it stops, right? It only runs one time with one number, and you have to start it over again to put another number in, right? So you can use any input. So first time, if I ran it with a 5, what was it? What's the answer? 10. So then I'm going to stop. And so it's going to stop unless I say, okay, let's run it again. But every time I have to go up and run it again. But there's something called a loop that you can, because if you wanted to run that program 10,000 times, that would take you forever, right? You have to keep starting it and starting it and starting it. But there's something called a loop that lets you repeat a series of steps. And one thing that we're going to learn how to do is avoid an infinite loop, because a program will do that. And over in MindTap, there's a couple times that students have trouble with where that happens, and it just goes on and on. It never gives you your output because it's in an infinite loop because you didn't give it any way to get out of the loop. And that's about, I think that's not till chapter 4 or 5 that we really go into detail. But right here is an inefficient way to do it. You could put 10,000 of these at a start and a stop, right? But look how many more. They only did 3 times. And so it'd take 9,997 more times. Your arm would be falling off, or your copy and paste would be. Okay. So you could, but it's very inefficient that way. So we're going to learn how to do a loop, which would look like this in a flow chart. Input my number, my answer equals my number times 2, output an answer, and come back up here. But what's wrong?
No stop.
No stop. So that would be a fatal flaw, they say, because it would be an infinite loop. So we can use a decision to test a value, and that's where we use a diamond shape. A dummy value is a data entry value that the user will never need. So you might use a -1 and say, keep doing this until the user enters a -1. When they enter a -1, drop out of the loop. Stop. Okay, that's called a sentinel value. It's a dummy value that will cause the loop to end. Another way you can stop the loop is there's something called EOF, which stands for end of file. And that comes from procedure programming, which we haven't really talked much about, but that's all there was when I started coding, was procedural oriented, which meant there was always a start and a stop somewhere. And in a file that you read in, if it was reel-to-reel tape or dispatch, there was always a little marker at the end, like maybe the dummy value was coded on that file. And so when the program come to that little mark, it knew to end. Okay, and that was called an end of file marker. And that's what you'll see in the book some. Like here says, don't do this, because here the logic starts here. Here's our diamond-shaped question. It says, is my number equal to 0? Yes, it is. Then stop. No, then keep going. But the problem is this logic is not structured. You will learn about structure in chapter 3. This would really work, but it's not structured, and we'll talk about that in chapter 3. But here's the end of file where you go out to the stop. So what is the text editor that we used the other day? What was the one we used for Python? We used PyCharm, and who else said idle? Yes, and we used idle. So we can use either one of those. IDE stands for Integrated Development Environment, and all languages you will have a different IDE, like the editor, the compiler. Microsoft Visual Studio IDE actually lets you program in quite a few different languages, and that's free to you when you're on campus here. If you don't know how to get Microsoft Visual Studio, there's a place you can go to and download it to your home computer. Okay, understanding user environments. Command line is a location on your computer screen at which you type text entries to communicate with the computer's operating system. We won't be doing that. A graphical user interface, or sometimes called a GUI, or most of the time it's called that, allows users to interact with a program in a graphical environment. First graphical environment was a Mac, and then Windows came about. Microsoft developed Windows. And so Windows started using a mouse, but Mac had them for a long time. They were used in educational environments first. Did any of you have one of those real old ones in school? Yeah, some of y'all did. Okay. So Apple IIs and Apple IIcs, those were some of the ones that were used in schools first. Now they're Intel processors just like the PC, so you can run Windows on here also. So here's a different programming environment here. This was just an example of a C# program. Here is something that kind of looks like Python, but it's an editor. It's using Microsoft Visual Studio. This one is a command line. See where it says cmd.exe? This is a Windows command line here. Here's the one that we went over last time in class 2, a GUI. Understanding the evolution of programming models. This is the ones that were in the 1940s. It didn't progress near as rapidly as it has in the last 20 years, how much easier it is to program. Okay, here's where I was talking about procedural programming. Focuses on procedures that programmers create. Object-oriented programming focuses on objects or things and describes their features or attributes and their behaviors. And this is the only thing that you all have ever seen, because the graphical user interface is an object-oriented environment, and the internet is an object-oriented environment. But you can create little tasks that are really procedures, like that last, the input number and my answer equals the doubling program. That's a procedural program because it's not talking about an object. It's doing a procedure of doubling a number, right? So it's called a procedural. So that's the end of chapter 1. And so now we're going to go out and look at some of the exercises that are at the end of the chapter. So any questions about all that I went over? Or those of you that's taken Unit 1 test, did you have any questions when you were going through about how they came up with that answer? Several of you did take it till 100%. It's up to you whether you want to do that. There's also these flashcards that will help you with the terms. Okay, so this test, yeah, it's available until 11:59 tonight. So if you don't take it by then you won't be able to take this. It's worth 10 points, all right? So we are also going to do that coding problem, but I wanted to do a few exercises first. So let's go to the end of the chapter. And also to make sure if you understand the terms, you can do the review exercises. There's all the key terms. These exercises, these are the review questions. These are just for you. That just because I don't have you turn them in doesn't mean that it's not a good thing for you to go through. If I used to go through these, but I found that students are more successful in this class if we spend more time working problems in class. And you go over these, this is what you have to do yourself. And I will answer any questions you have if you don't understand the answers, okay? But if we take time to do this, then we don't get to solve problems. And that seems to be the thing that helps students the most. So now this first one in the programming exercises was to match the definition with the appropriate term. And those are important too. Then one of your exercises, or your Unit 1 programming exercise 1, I think, was to do number 2, which was simply to, in your own words, describe the steps to writing a computer program. So you still can go back to the chapter and find those steps, but you don't have to write them verbatim. You can shorten them if you want to. And so you can do that in Lucidchart. You can drag over a text box and write the answers in there, type in the answers to number 2, or number 2 you can put in a Word document, whichever way you want to do it. But number 6 that I assigned, I believe it's number 6, isn't that right? Yeah. Okay, that one has to be done in Lucidchart. And remember, I said I want a flow chart and pseudocode, even though the problem says or. Because on these first ones, we're going to do both. But you don't do Python. You just do pseudocode and a flowchart. And so if you have just one document in Lucidchart, you would have problem number 2 up here, and then you would have problem number 6 answered, okay? And it would be the only one that has pseudocode and flowchart, right? Okay, so now what we're going to do is we're going to go back and do a couple of these above that. So we're going to start with, and if you don't have any problems with it and you don't want to do it along in class, that's fine. But this is the way that I find students learn the most. So go out to Lucidchart. And so you will want to sign in to your computer. And if I'm going too fast and you want to follow, let me know and I'll slow down. If you're just wanting to watch, that's fine too, whichever way you learn best, okay? So we're going to go up here and get a blank sheet. And I'm going to look over here at this problem number 3, and it says, draw a flowchart or write pseudocode to represent the logic of a program that allows the user to enter a value. The program multiplies the value by 10 and outputs the result. Okay, so how many input variables do we have for this problem? 1. Okay, and we're going to give it a name. And what is the processing step going to be? We actually will have only one input variable, and then we have to have another variable for our output, right? So we'll say mult 10 or something will be our variable name. And what will our processing step do? Yeah, it's going to get the answer. How's it going to, what's the calculation for this one? How am I going to find out the answer? Cool. Yeah, my answer, okay, it's going to equal whatever you call the variable times 10, right? Everybody see that? That's the part that is your processing step. And then you're going to output the result. So that means that result has to be the same variable name that I used in my processing step. So I'm going to take this, oops, and copy it, I think. Come on, let me copy it. I don't want to highlight it. Copy. Okay, so I'm going to go over here to Lucidchart. And you don't have to do this part. I'm going to put the problem over here so that I don't have to keep flipping back and forth, but you don't have to do that. Okay. No, this is Lucidchart. Oh, MindTap, the problem? Okay, I went to the read the chapter, and this is the chapter contents. Did you find it? So like if you were going there, you would click on read. And then the chapter contents is where I found the exercises are at the bottom. And so these are where at the end of every chapter, and even if I don't assign all the problems, the more, if this is your first time with coding, the more of these you work, the better you'll be. I just can't grade more than about 1 a week because I have 67 students taking this class. So you can just kind of calculate. What'd you say? Oh, you're helping him find it. Okay. Okay, so here's the problem. I just put it in there so I don't have to keep going back over to MindTap, but it's not necessary for you to do that. Okay, so we're going to do the pseudocode first. So I'm going to drag a text box over here, and I will enlarge the font so that you guys can see it, but you don't have to do that. Okay, and I want my text to be aligned to the top, so I'm going to pick the alignment there. I'm going to change my font to something easier to read. They don't have Verdana, why not? They used to have it. I don't know why that's not in there. Oh, well, we'll just use that one. but I'll make it bigger. Let's go down to 24. Okay, so I start my pseudocode with start. Oops, what did I do? Uh-oh, something messed up. I drug it. Come on. That's my flow line. I don't know why it's, oh, I see what I did. All right. So I wasn't inside there, I guess. Start, then remember for my program, I'm going to indent. So I can say input, and I can call my variable anything I want. It's just a number, so I'm just going to say num1. You can name that. That's your choice, okay? Whatever makes sense to you for the problem. That's a variable name. The next one, I'm going to be my processing step. And remember, my result is always first in my calculation. So I'm going to call it, I can call it anything. I'm just going to call it mult 10, okay? Because I'm multiplying by 10, right? Equals num1 times, what do I use for times? Asterisk 10. And now I want to do my output. So I'm just going to start using print because that's what Python is. But if it makes more sense, because I told you you have to have input, processing, and output. So you can use output if you want, if that makes more sense. Print. And what is my variable name that I want to print? What's the results? What's it called? You know. What's your answer? What's it called up there? What did I name it? Instead of my answer, what? Mult 10. Mult 10, okay? So this means if it made more sense to make that my answer, you can call that variable my answer. But if I do, oops, if I do, then I've got to be sure that this is called my answer, or else it wouldn't know what mult 10 is, right? So you can do it either way. If this makes more sense, then you can do it that way. And then I would say stop. Okay. Questions. Ask me if you don't understand why it wasn't num1. You could print num1 so that you'd know what the user's input was, but you have to print what your answer variable was. You used num1 in order to get the answer, right? So you notice I changed the name here, but it has to be changed in both places. So if you have the first one, I put mult 10, that's fine too, just so you have mult 10 in both places. Questions? If you have a question, somebody else does too. So be sure to remember there's no dumb questions, okay? There's always somebody that's thought that same thing. All right, so now I'm going to start with the flow chart. So I'm going to pull over a terminal and I'm going to change it. I can get to start, and I might want to make it bigger also. At least to maybe 18, something like that, so y'all can see it. Then for my next shape, remember I can click here, and instead of having to pull it over from the left, and then it connects it with the flow line automatically instead of me having to go up here and drag a flow line down, okay? So my next one, what do I use for input? What kind of shape? What? Parallelogram. Okay, so the parallelogram is going to say the same thing that's in my first line of pseudocode. So I'm going to say input num1. So the thing that I'm going to be looking for is consistency in your names. So be sure if you used num1 over here in your pseudocode that you use that same one in your flow chart. If it bothers you when the line is crooked, it's hard to get it straight. Once you make the shape a little larger, it's kind of weird. It doesn't want to sometimes straighten up. Okay, so there's the parallelogram. So next shape is going to be my processing step. So what shape is that? Rectangle. So that's this one. So now I'm going to say, actually what I used to do if it's a long line of code, I just come over here, copy it, say, if you like to type, then you don't have to do that. Now, because that's so big, I'm going to have to make it smaller, right? It's not going to fit in there at all. So now I'm going to mess up my line, my flow line again. Let's see. There we go. Okay, now I may want this in the center this time, so I can go up here and say align center. You don't have to. That's just if it bothers you. Okay, so then what shape do I need next? Parallelogram. Good. So now I'm going to say print my answer. And I'll make it a little bigger here in a second. If I can make it where it's not crooked. Okay. Here is 18. And so what's the last shape that I need? Which one? Oval, terminal, symbol, correct. So this one says stop. Okay, any questions? Pretty simple, yes. How do you find it?
Yeah, I can find it.
Okay, did you do that this way or did you come over here and drag it? Okay, it's going to be right there. It says data in it too. It says data in it. Uh-huh. All right, so now if I was going to require that this be a problem that you submit, remember I go over to File, and then I click Download As. Only yours says Export, right?
Yeah.
Okay, yours says Export As. So use Export As and click PDF. And then you're going to come over here and pick Download and give it a name. So let me go back to, that's not what I want. Fundamentals. Oops. Okay, so this is the, yeah, this is what we're doing. Okay, this one is called exercise. This one was exercise 3, and it'll automatically put PDF. So now I have my PDF file where I can submit it, but don't submit this one, not necessary. So that's what mine looks like if I open it. Okay, everybody all right? Any questions? Okay, we can put this little one in Python, but we're gonna go a little bit further first. We're gonna do another one and then we'll put them in Python. If you do the program in the home, let me find that. Oh, I'm gonna go back and take attendance now. I don't think anybody else is gonna come. Joseph Bond. Joseph. Okay, I'm going to try to look at people. See, I see you all twice a week. Maybe I'll learn your names. Brendan. Yeah. Brendan. Okay. Samuel Dolzel. That's the one that didn't come at all. Ty. Okay. Alex Freeman. There you go. Mark Jeffrey. Mark back there. Zachary Hall. Okay, Zachary. Gabriel Hill. Okay. Catherine Howell. Isaiah Johnson. Oh, you're Isaiah. Which one's Mark? Is Mark here? Mark Jeffers. Okay. Jeffrey. No, he's not here. Okay. Yeah, and it'll help me if you load your profile picture up in here. Then I'll remember, I'll be able to match the names with the faces. Haley's right there, right? Caitlin, I know. Lainey, I know. John Blaine. Do you just go by John? Yeah, just John. Okay. Adage. Is that right? Mm-hmm. Okay. Chase. Yeah. You put a different picture. I don't know. So did Lainey do that. Okay. Samuel Nixon. Okay. So that's the other Samuel. I think there's another Samuel too. You're Samuel White, right? No? You just tell me who you were. Jamie is back there. Colby, I remember. Samuel White. Samuel White. Okay, he was here the other day. All right. So we already have some people who decided they can't do it, I guess. No. Okay, so here is where we're at today is module 1 we haven't quite completed yet. So these were the exercises that I'm talking about where you'll submit one of those that we just finished, but it's not that one. And then this is the one with the tutorials where he teaches you to install PyCharm and does a couple of coding things. And there's the executing the code in Python. But right now we are going to go back here and back to MindTap, and we're going to do one of the little bit harder ones. Let's see. I gave you 6. Well, we might have time to do them both because they're pretty short. Okay, so this one is for people that like geometry. Who likes geometry? Anybody? No? Engineers should. No? I mean, you have to look it up. Yeah. Yeah, I do too. I don't know. Yeah, what's this? Did you already look it up? Yes. Oh, good. You can help us then. Okay. All right. So we're going to, this one, let me copy it over there too so that we don't have to flip back. Oops. All right. So I'm going to start a new file. So I'm going to do File, New Document. So you click on File, New Document, Flowchart. I don't know why it did like that. Blank. Here we go. I don't know why it did it that way. I'm not going to do it that way. You can add also a new document another way. Where is that? Here, maybe. There we go. You can click on that little file folder. I guess you had it. And then just say add blank. Okay, so now I'm going to put the problem over here first, so I don't have to keep reading it in the book. Okay, so this one has a little bit more to it, and I need to do the alignment. I don't know what that is for sure, but keeps digging on here. All right, so this one says, draw a flowchart or write pseudocode to represent the logic of a program that allows the user to enter a value for one edge of a cube. Okay, so I'm going to get another text box over here and get it set up for my pseudocode, right? Top left, did like 24 so you can see it. Make it a little bigger here. Okay, then it says that, so our answer to enter a value for one edge of a cube. So how many input variables? how many things does the user get to enter?
One.
One. Okay, so they're going to enter a value for one edge of a cube. And then it says the program calculates. So this is going to be the calculation in the processing step, right? The calculation says that you're going to calculate the surface area of one side of the cube and the surface area of the cube and its volume. The program outputs all the results. So how many output variables are there? 3. So we're going to have 3 calculations, right? I think there's actually some that can be combined, but we're going to do it 3 separate so it won't be confusing. So we're going to do a start. Now everybody knows this statement. I want to hear somebody that hadn't answered yet. Very first statement is our input, right? So what are we going to input? Come on, somebody that hasn't answered. What did we say we were going to input? There's one value, edge of a cube, right? So what we can call it that, right? We can just name it. Let's just call it edge. So, oops, I've got to put input first. Input, and we're going to call this variable edge because that makes sense, right? That's what it's asking for. Okay, this is the harder part that John's going to help us with because he already looked up the formulas, right? Okay, so we have to calculate the surface area of one side of the cube, then the surface area of the whole cube, and its volume. So which one needs to be first? We have to find out what the surface of one side is in order to be able to calculate the surface of the whole cube, right? So we need to know surface, let's say surface side, because that's what this is going to be, right? So we're going to name this variable surface side equals, and what's the formula? Edge times edge. You can, but we don't know how to do that in, we don't know how to do that yet in programming. But yes, you are correct, Samuel, right? You're Samuel. Okay, what he said, can we just do edge squared? Because that's what edge times edge is, right? It's edge squared. But we're going to do it this way for now. Okay, so edge times edge. And now we've got to know what the surface area of the whole cube is, right? So we'd say surface cube. Let's call that answer. Do you understand that all of these are what my answer was when we only had one calculation, right? But now we've got 3. So we've got to have 3 separate variables. Okay, so what's the surface of the cube? Anybody else look it up or else do what? What's that? Who said it?
Edge squared times 6.
Edge squared times 6. Is that what you looked at? Pardon?
It's the surface side times 6.
Yeah, so you, but it's what he said, surface side times 6, right? So it's exactly what you said and somebody else over here. But since we already calculated edge squared, then we're going to use that variable and then we're going to come up with a different way to do it. Side times 6, right? So we could have said what's your name? Joseph. We could have said done what Joseph said and said edge times edge in parentheses times 6. But since we did it in the statement above, then it'd be better to use that one. So now the last thing that the problem asks us to calculate is what? Volume. So here we'll say volume equals, what's that formula? Is that what it is? Edge cubed, right? So it's edge. So we could say surface side times edge. Will that work? Mhm. So we could do it that way, or we could do it the way Samuel said, edge times edge times edge. So now, what's the last statement of our program? We got one more thing, output, because we don't know what those are unless we output. So this time we'll use output instead of print. Output is, told us to do each one of them, so we'll say surface side, surface cube, and volume. I'll have to make it really big. Okay, and so now, Samuel, what do we do next? Now we put stop, right? All right, so that's the pseudocode for that problem. Now, instead of doing the flow chart on this one, I'm going to let you figure it out, but it's not hard because I want to do a little Python. We won't have time to do both, okay? So we've got this one figured out, and now we're going to go, and this time I'm going to use PyCharm. So on the Windows machine, PyCharm is there, it's on the desktop. So if you go out of Google Chrome, you can minimize Chrome like this. Oops, where'd mine go? Come on. Yeah, there it is. And so PyCharm, if you want to use PyCharm, anybody going to use PyCharm on your Windows machine? Okay, so it is on the desktop, right?
Yeah.
Okay, so minimize that. And see where it says PyCharm right there on the left, where it says PC. That. Double click it. And whenever you do the tutorial video of the guy, he shows you how to load it. Okay, it's not going to be in that, it's right there.
Okay.
It is in that other list too,
Okay.
but that's the easy way. Everybody find it? It doesn't look like that. PyCharm is down here. So my PyCharm is down here on the Mac.
Do you want us to send the usage statistics or dump?
No, you don't need to. Okay, so once you get PyCharm open, let me see, it's probably going to open different. Did you find it here? No, that's idle. That's what we used last time. So you won't have PyCharm on there unless you've downloaded it with that tutorial guide.
Okay.
You can do it in idle though. You can do it in this one like we did last time.
Where's PyCharm?
PyCharm's on the desktop. There's a
Oh.
icon for it. Yeah, PC. Everybody find it? Oh, and how does yours come up? Well, that's what you were asking. Do not. Is that how when yours? You just click on it.
Okay.
You just did that. Oh, yeah.
Thank you.
Oh, do not import settings. Just click OK. And then it says JetBrains. So, oh, did you have to scroll all the way down? Oh, press the check. Okay. Now what's that one? Send, no, don't send. That doesn't matter. Okay, okay, so yours opens up a little different than mine. Yes, skip the tutorial. Yeah, you can skip this right here. That's the tutorial thing. Now when it opens, let me see what else does. Yes. So yeah, you should eventually get to where it says create a new project or open. And this time we're going to create a new project. And what the guy in the tutorial that I have you do on variables, he'll explain all of this to you, but this is the name of your project where it says Untitled 1 at the end of that line right there. So you need to name, like we're going to name the first one we're going to do was EX3, right? So we're going to call it EX3, and then everybody should say 3.6 right there, because you want to be sure that you're not in the 2.7, which if you do this drop down, it lets you do 2.7. Don't do that. That's a totally different version of Python. Not letting you do what? Oh, well, maybe it doesn't. It probably doesn't have it on there anyway. So just click create. Yeah, your lines may not be on there like that.
What do we need to go to get inside?
Yeah, that's it.
This one?
I know you do that.
Just,
Yeah, they did put the professional one on these PCs. Okay, so I'm going to click create. And when it creates it, it should, and I know that's tiny there, you'll see a folder over here to the left. That's your project right there. Well, it actually starts up there. Right. And so then we're going to go here. Oops, why did it do it that way? No, that's not right. Should be able to click there. On right click on EX3 or whatever you call that down below, and then click new and click Python file. Right, see that? You probably can't see that far, but you guys in the back know how to do it that can see. Catherine, did you get it? Okay. Yeah, whatever you want to know. Then we're going to click Python file. And so if it was easier for you to do in idle, you can do it in idle, but that guy in that tutorial is going to show you PyCharm. The difference, PyCharm lets you debug right below. You don't have to open another interpreter window. That's one of the things that's good. So here, the new Python file, I can still call it EX3. Okay. And that's my Python file. And you see number 1 up here is line 1. So if I go back over here, and you don't have to do this because I'll open it for you, and we look at our, we'll do this easy one first because we don't have time. Okay, this one is input num1. So you go ahead and type, oh, come on, PyCharm, where'd it go? Okay, type in our input statement, and remember the way you do that in Python, and you probably don't, but he'll show you in that tutorial that you do, but our input variable was called num1, so I have to start with it is equal to input, and remember I can do an integer. Oh, I got to do it backwards. Integer. Oh, wait, which way did I do it before? I can't remember. Input, int. I'm not sure if I did it right. Int. Please, oops, got to enter a number, right? Please enter a, oh, mine's doing all caps. I'm gonna run out of time. Please enter a number. It's that one, and then I gotta have one more. And then what was my process step was like, I called it my answer, oops, answer equals num1 times, was this the one that was times 10, wasn't it? Times 10. And then I can say print my answer. And then I just say run right up here. And there's 2 ways you can run in PyCharm, or more than 2. There's also a little arrow right here that just means run also. So you can do it either way. You can say run, run. And when you say run, it's going to ask you that one, yes. It puts the answer down here below. And look, I have an error because I did it backwards. I always forget that which way. Okay, so it should be int out here. So what it's telling me, num1 equals input. Yeah, that's what it is. Okay, so this should be int here and input here. I'm not a Python guru. I think that was what it was saying. So now I can run it again. Yeah, and there it says, please enter a number. It's kind of tiny down there, so y'all can't see it. And if I enter 5 times 10 is 50, process finished with an exit code of 0. You see, when I did idle, you remember I had to run it and it put up another window. Whereas with PyCharm, it'll run it right below, and any errors that show up there, you can go up there and correct them. And I'll get my PyCharm set up. I fixed the editor window where it was large enough for you to see, but I forgot to go in and change these preferences too. But this is PyCharm. So you have a video where I did one in idle, and you can use either editor that you want to. Doesn't matter. When you get into script programming class, the next class, of course, my multimedia students, some of them take that and some do not. They will use PyCharm. That's why I wanted to introduce you to it this time. So you can use it or idle, either one, but neither one of these are assigned in, oh, I got rid of, I guess. Let me get back to my Chrome somehow. Okay, let's get down here where our class was. Oh, it went away somehow. So what your assignment for tonight, or I mean that's due by midnight tonight, is that Unit 1 test. But then also these are, this one is due this week. Next Monday we do not meet. It's a holiday. So these are, but you'll notice that the due date is that night at midnight. That's Labor Day weekend, right? Is that right? And so with this one and this one, you're to do before next Wednesday, okay? But then like this one, we're going to do in class on Wednesday together. So those of you, I don't know why I have a September 16th date, because this is in your coding for chapter 1. And I know some of you guys are way ahead and you're saying we're going so slow, but you know, some people, this is the first time they've ever seen this. So we're going to take this first part slow. And so if you are having trouble, you need to ask questions, because I don't know if you don't ask questions, okay? So you go back and you can try to do more of those, or that one that we did in Lucidchart, and put it in Python. So even though you just have to upload one to me and you have to do this section, you do as many as you can to be sure that you know how to do it, okay? So do those exercise problems, work on those at the end of MindTap until you understand them, and we can do some more in class also on Wednesday. Okay, see you guys on Wednesday then.